Hello class. So as you can tell from the videos that you watched before this, we're finally getting into calculus. And as you know from those videos, when we find the derivative, what we're doing is we're really finding the rate of change at a single point. And in order to do so, we use the difference quotient. And that is saying this: the derivative of f, or f prime of x, that's when you see the little apostrophe, that's called x prime of x. That's just one of the notations we use to denote a derivative. Is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So think about what's going on here. When we have a slope of some sort, right? We take some value and subtract it from some other value, right? Over, well, I'll just write it down. The let's see, like y sub 2 minus y sub 1 over x sub 2 x sub 1. We have something like this. And I know they explain it in the video. I just kind of want to explain it as well. We have some point subtracted by some other point, divided by that point, subtracted by the x value of that point. But what if we want instantaneous change, right? What if we want change right at a point? Well, wouldn't it make sense that we would want the x sub 2 and x sub 1 to be the same value? When we subtract, it would essentially be 0. That's why we have h on the bottom, and we have as h approaches 0 of this. So we're going to use the difference quotient to find the derivative of f of x equals 3x plus 2. And this is exciting because this is the first bit of calculus we've actually done up until this point in our calc class. So let's see. I have my f of x. This is my f of x, but I need my f of x plus h. And all you need to do to find that is just every time you see an x, just add an h to it and put it in parentheses. Okay? So, for instance, my f of, you don't have to write this down all the time, but my f of x plus h is going to equal 3x, or sorry, 3x plus h plus 2. I hope you see what I did there. Just there was an x here, I just changed it out with an x plus h. That's all you got to do. So let's plug this in. We have f prime of x, our derivative, is equal to the limit as h approaches 0 of f of x plus h, so this one over here, 3 times x plus h plus 2, all over 3x plus 2. No, I'm sorry. What am I saying? 3x plus h plus 2 minus, and then our f of x, 3x plus 2. And you might be wondering, well, why did you put that in parentheses? Well, the reason I put it in parentheses is because very important, we need to distribute this negative here to both terms, or all terms if there are more than 2. And then all divided by h. So this is essentially the derivative. We just need to do some simplification. Now, the algebra will get tough in this. Not necessarily with this one, but as we go on, you'll see that it gets a little tough. So just be careful. Maybe double check what you're doing from time to time. Okay, so let's simplify this. So first, what I kind of want to do here is I want to get rid of the parentheses. So let's distribute this 3 to the x and h, and distribute this negative to the 3x and the 2. So that's going to make this look like the limit as h approaches 0 of 3 times x, which is 3x, 3 times h, which is plus 3h, plus 2, nothing to do with that 2, negative times 3x is minus 3x, and then negative times 2 is negative 2, all over h. Now, this is what happens here. And you might already see it. We have a lot of things that cancel out, right? For instance, we have this 3x and this negative 3x. We have this 2 and we have this negative 2. So I can just cross this out, and cross this out, and cross this out. And what we have left here is simply the limit as h approaches 0 of 3h over h. And you might be able, oh, that's a weird looking h. And you might be able to see one more thing we can do. We can cancel out this h, which means the limit as, not x, as h approaches 0 is just equal to 3. And that makes sense, because doesn't the derivative give us the slope of the function at all points? It does. It gives us a roadmap of what the slope is at any given point. And look at this. In a linear function, the slope is always 3, isn't it? In this case, we got a slope of 3. So we just did a derivative. We took the derivative of 3x plus 2, and it's 3. Let's take a look at something slightly more challenging here. Let's say now we have f of x is equal to 2x squared minus 4. So, you know, I'm going to write our difference quotient just so we have it. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay. So again, we need to first find our f of x plus h, which is easy to do. You just plug in an h, or you add an h to wherever time you see an x. So in this case, our f plus h is going to, or f of x plus h is going to be, let's see, it's going to be 2 times x plus h squared. Notice because the x is squared, so now this whole x plus h is squared, minus 4. And now we just have to plug it in. And as you can see, this one's going to be slightly more challenging than the last one, just because of the algebra here. So let's say that we have f prime of x is equal to the limit as h approaches 0, and I'm just plugging it into the difference quotient, of, let's see, 2x plus h squared minus 4 minus our f of x, which is going to be 2x squared minus 4, all divided by h. Now, again, this is the derivative, but we need to simplify it. I mean, this makes no sense to us in its current form, right? So let's go ahead and simplify this, and this square. Let's deal with this square first here. That's going to look like the limit as h approaches 0 of 2, and you know, I'm going to write this out just twice because that's really what the square means. It's just multiplied by itself twice, minus 4. And then, you know, let's get rid of this parentheses while we're at it. Negative times 2x squared is minus 2x squared. Negative times negative 4 is positive 4. All divided by h. Now, let's multiply all these together. Let's get rid of these parentheses now. In order to do so, we need to FOIL. Oops, losing my pens. Okay. So we need to multiply this x to both of these and multiply this h to both of these, and we'll deal with the 2 later. Okay. So the limit as h approaches 0 of 2, and let's see here. X times x is x squared. X times h is going to be plus hx. H times x is again hx. And then h times h is h squared. And then just with this stuff, minus 4 minus 2x squared plus 4, all divided by h. And then now let's distribute this 2 to get rid of all of the parentheses. So limit as h approaches 0 of 2 times x squared is 2x squared. And then we can combine these, can't we? Isn't it this h of x plus h of x? Isn't that 2h of x's? Isn't that 2hx if we were to add them together? So let's just do that in one step. So let's multiply 2 times 2h of x, okay? Again, this 2h of x, or 2hx, I got just from adding these two together. We haven't multiplied yet. So it's going to be 4 plus 4h of x. Hope everyone's okay with that. Plus h squared minus 4. Oh, I goofed. I didn't multiply the 2 to the h squared. Plus 2. That looks funny. H squared minus 4 minus 2x squared plus 4 over h. And again, you may see a lot of things cancel out. And this is the nice part, is cleaning this thing up. So notice that we have 2x squared here. 2x minus 2x squared. We have a negative 4 and a positive 4. And it looks like that's everything that cancels. So let's just rewrite this so it looks nicer. The limit as h approaches 0 of 4hx plus 2h squared over h. Oh boy. Okay. Now, in our last example, the h's canceled out immediately, but they still cancel out. But let's factor out an h at the top so we can see it clearly. Because notice both terms on the top have an h. So the limit as h approaches 0. Now I'm going to pull out that h, and we're really dividing both of these terms by h. So 4hx divided by h is just 4x. And then 2h squared is just going to be plus 2h. So the second h is out here, divided by h. And then now we can cancel those out. So really, this is the limit as h approaches 0 of 4x plus 2h. Now, what happens to this as h approaches 0? Well, isn't it true that if h becomes 0, then this zeroes out? Absolutely. So the limit as h approaches 0 is just 4x. So if we go back up to the top, 4x is the derivative of 2x squared minus 4. This is a lot of algebra, isn't it? Let's do one more. And again, I'll just write the difference quotient up here. I wouldn't say that this is necessarily challenging, it's just very tedious and time consuming. And the challenge is just making sure that you got everything all right, you know, as opposed to making mistakes here or there. Okay. All right, so, oh, yeah, I need an example, don't we? So, we have, let's see, f of x is equal to 3x squared plus x minus 1. All right, so right off the bat, let's just write out our f of x plus h. So f of, let's see, f of x plus h is going to equal 3 times x plus h squared plus x plus h minus 1. And as you can see, this is going to be a real fun one to do with these three terms. So I guess we just got to Got to dive right in. Okay. So it's going to be f of x plus h, which will be... Oh, I might as well write. Hold on. F prime of x is equal to the limit as h approaches 0 of f of x plus h. So it's going to be 3 times x plus h squared plus x plus h minus 1, all divided by h. And, okay, so again, let's, it's so long I forgot the f of x. It's minus f of x. So minus 3x squared plus x minus 1. Okay, now we have our f of x plus h minus f of x over h. Okay, so let's see here. This is going to be the limit as h approaches 0, and I'm going to write this out. Well, you know what? Because okay, whatever. We'll just do it. Okay, x plus h. I was going to say there's a shortcut you can do if you've done enough of these, and if you're comfortable doing it, you might as well. So minus 1, and then I'm going to get rid of these parentheses while I can. Negative times 3x squared is minus 3x squared. Negative times x is minus x. Negative times negative 1, positive 1. All over h. Okay. So again, we're going to FOIL this front part here. So we're going to have the limit as h approaches 0 of 3 times, now x times x is x squared. Now this is the shortcut I was saying. We're going to have plus 2h of x, because it's going to be x times h, which is one of them, and then h times x, which is another one, which is going to be two of them, and then plus h squared. Then I'm going to get rid of these parentheses. I don't know why I wrote them again. Plus x plus h minus 1 minus 3x squared minus x plus 1 all over h. This makes the quadratic formula look like pretty easy, doesn't it? Okay. So let's get rid of these last parentheses here. We're going to distribute this 3. The limit of h as h approaches 3 is going to be 3 times x squared, so it's 3x squared. 3 times 2hx, which is 6hx. 3 times h squared, which is plus 3h squared. Plus x plus h minus 1 minus 3x squared minus x plus 1 all over h. Okay. Wow. So now it's time. Now we can cancel things out. So I have a 3x squared here minus 3x squared there. Let's see, what else do I see? I see a positive x, a negative x. I probably shouldn't x them out with x's. That just makes it look confusing. And live and learn, though. And then we have negative 1 and a positive 1. So what we're left with is the limit as h approaches 0 of 6hx plus 3h squared plus h divided by h. And again, we can factor out an h out of everything on top. So we have the limit as h approaches 0. I'm going to factor out this h, which really means we're dividing all of this by h. So 6hx, which is going to turn to 6x. 3h squared is going to turn to 3h. H is going to turn to plus 1 all over h. And then finally, cancel out that nagging h on the bottom. So the limit as h approaches 0 is really 6x plus 3h plus 1. Now, as h approaches 0, isn't it true that this middle term zeroes out? Because it becomes 0. 3 times 0 is just 0. So really, it equals, it's the limit as h approaches 0. Well, no, I've actually already, I don't need to write that again. It's just going to be equal 6x plus 1. And that is our derivative. That's some fun stuff. This is really fun, to me, anyway. Alright, so that's all I have for y'all. I hope you enjoyed this video, and I hope you enjoyed the other videos. Sorry you've been watching a lot of videos lately. It's just kind of important to not only understand the mathematics of this, but also why it is such. So that's all I have for you. Have a good day.